I thought we could probably use a little bit more antiderivative work. I thought I'd choose some a little bit more complicated problems. Okay, so this is kind of like when we were doing derivatives. In order to use our power rule, we had to write everything as a power, and the same thing is true when we're doing the antiderivatives of things. So I want to, I'm going to rewrite this first. So this is just my rewrite step, is x to the negative 1/2. It's square root of x, so it's a half, and it's in the denominator, so I pull it up calling it negative. Then this will be plus 2x to the positive 1/2 plus 2/3 dx. Now, I technically probably should have parentheses here, but it just makes it kind of look messy. All right, so now I'm ready to use my power rule multiple times, right? I'm allowed to do them separately because I have the rules say I'm allowed to. So that means I'm going to use my power rule here. So I have x to the negative 1/2 plus 1 is positive 1/2, and then I'm going to divide by 1/2. We're going to simplify that. Okay, and then plus 2x, 1/2 plus 1 gives me 3/2, and then I divide by 3/2. And then this is just the 2/3, so it's a constant, so it gets an x, or whatever variable this is, right? And then a plus c on the end. So to simplify it here, really, what I do when I go to divide by a fraction is I just write the reciprocal over here, because I'm going to multiply the top and the bottom by the reciprocal and get 2x to the 1/2 here. And then if I multiply the bottom, or I'm going to multiply by 2/3 here, I'm going to get 4/3 x to the 3/2 here, and then plus 2/3 just gets an x plus c. And I didn't have any initial conditions, so that's just my antiderivative. All right, so this time I have some multiplication, and there is absolutely no product rule for integrals. So that means we have to multiply this out before we can do anything with it. So I am just going to multiply. So I'm going to multiply this by this, and I get x cubed. So then my outer terms are 3x squared. I get an inner term of 1x, and then I get a last term of 3. And so once I've done my multiplication, now I'm just using my power rule a bunch of times. So this is now equal to, I'll just write it over here. I should actually put that that's equal here. I should say something about something being equal. Okay, so then I have x cubed. I add, let's move this up here before I write out the screen, x to the 4th over 4. And then I have plus x cubed, 3x cubed over 3, plus x squared over 2, right? It's an implied 1 power. And then plus 3x plus c. Now simplifying a little bit, because I have this here that I could simplify a little bit, so I could say this is 1/4 x to the 4th plus x cubed plus 1/2 x squared plus 3x plus c. So if I wanted to call it my big F, right, because it's my antiderivative, I could call it that, right? Because we usually say the antiderivative of little f is cap F, the antiderivative. Okay. All right, so let's do another one. So this one involves division. So there is also no quotient rule in my antiderivative repertoire, so I need to actually get rid of this and divide first. So I have a couple of different options. Either I can call this x to the -2 and multiply it all through here, or I just prefer to break them up as individual pieces. So I'm just going to write, when there's only one term in the denominator, I can write each one of these terms as it over it. So I have x squared plus 4x squared over x squared plus 6x over x squared plus 1 over x squared dx. So simplifying here, I will have just plain x here, and then I'll have plain 4 here because these x squareds cancel. I'll have 6 over x here, so I'll write that as 6x to the -1. And then I have plus, this will be x to the -2 dx. Okay, so I'm ready to do my antiderivative now. So I have x squared over 2 plus 4x. This is my if I add 1 to negative 1, I get 0. So actually this is 6 natural log of x, little thing that happened in there. And then this will be plus x to the minus 1 over minus 1. Okay, so just rewriting that as my cap f is 1/2 x squared plus 4x, and then plus 6 times the natural log of x. So x to the minus 1 is natural log, the 6 just sets here. And then I'm going to end up with minus, I can write it as x to the minus 1, plus my c. Oops, forgot it up here. Sorry about that. Okay. All right, so I have some complicated powers here. All right, so when I do my antiderivative, actually I'm going to do one rewrite, right, because I do have this x cubed in the denominator. So this is x to the negative 6 over 11, and then plus 36x to the minus 3 dx. All right, so I'm going to have x to the, all right, so I'm going to add 1 to negative 6 11ths. So that is going to, I'm going to add 11 over 11. So that's going to give me 5 11ths. And then I divide by that new power. I'm just going to write the reciprocal here. And then I have plus 36 x to the, when I add 1 to negative 3, I get negative 2 divided by negative 2, and then the plus c. So here I have, if I wanted to write it with my cap f, is 11/5 x to the 5 11ths. And then this will be negative 18 x to the minus 2 plus c, simplified. Okay. All right, so let's do some trig here. So we have secant times 2 secant minus 5 tangent dx. Okay, so again, I have multiplication. There's no rule for that, so I'm going to just do the multiplication. So I have, when I multiply these two together, I get 2 secant squared x, and then I multiply these two together, and I get minus 5 secant x tangent of x dx. And that's good because I recognize these as derivatives, right? So the derivative of tangent is secant squared. So, you know, I could just I could rewrite this. I could rewrite both of these integrals as 2 times the integral of secant squared x. And I could write this as minus 5 times the integral of secant of x tangent of x dx for both of them. So then this is 2. This is the derivative of tangent. So it's 2 tangent of x. And then this is minus, this is the derivative of secant. So 5 secant of x plus c. And that is my antiderivative. All right, so how about if we have an initial condition here? So this time we're given the derivative, dy dx is 3 cosine of t plus 4 sine of t. So if I want y, which is really f of x, then I have an initial condition here, then I'm going to need to do the antiderivative here. So I know that my y will be equal to the antiderivative of 3 cosine of t plus 4 sine of t dt. So my y will be equal to 3 sine of t, and then this will be minus 4 cosine of t. Because it's always, I kind of remember that whenever I write the c, it's negative in this case. I know that's a difficult one. So now I want to get rid of my c because I have this initial condition here. So I'm going to plug in pi over 4 and plug in 4 for my y. So 4 is equal to 3 times the sine of pi over 4, which is the square root of 2 over 2. And then minus 4 times the cosine of pi over 4, which is also the square root of 2 over 2 plus c. Okay, so these are actually like terms. They're both root 2 over 2, and they have a constant in front. So I actually have 3 minus 4 here. So this is actually going to be negative. So I have 4 equals, so 3 minus 4 is negative 1, so I end up with negative square root of 2 over 2 plus c. So my c is actually 4 plus radical 2 over 2, and I will just leave it like that. So then I can rewrite my y now as my final step as writing it as y equals 3 sine of t plus, actually minus 4 cosine of t, and then plus 4 plus the square root of 2 over 2. And that is that one. All right, so let's do some words here. Okay, so we have a car traveling 30 meters per second, begins to decelerate at a constant rate of 3 meters per second squared. After how many seconds does the car come to a complete stop? All right, so the car coming to a stop, that means we want the velocity, right, how fast it's traveling, to become 0. So we are looking for where is v prime of this thing equal to 0. That's the question we are asking. Now we know that it's decelerating at a constant rate of 3 meters per second squared. That is really telling me that my a of t is negative 3 dt. Or actually, no, it's just negative 3, sorry. I'm a little ahead of myself. So now if I want velocity, actually it's just v, not v prime. If I want my velocity function is now the integral of negative 3 dt. And we have this bit of information here. So that means that v of 0 is 30. So when I'm in meters per second here, then that's the velocity. Whenever I have units over something squared, then that means that's my acceleration. So we know that v of 0 is 30, and we know that a of t, because it's all the time constant rate, is negative 3. Decelerating means that it's stopping, so we say that's negative. Okay, so we want to know when does the velocity hit 0. So first we need to find the velocity function. So our v of t would be negative 3t plus c. Pretty simple one to do the antiderivative of. Now we wrote up here that v of 0 was 30. So I'm going to set this equal to 30 and plug in a 0. So basically I'm going to get 0 plus c, so my c is 30. So that means my velocity function is negative 3t plus 30. Now I want to know where my velocity is going to be 0, because that's the first question. How many seconds does it take for the car to come to a complete stop? So we want to know when is the velocity, what time is going to give us a velocity of 0. So we set this equal to 0. We get negative 3t plus 30. I move the 3t over here, and I get t equals 10 seconds. I'm in meters per second. I'm in seconds. Okay, so it's going to take the car 10 seconds to stop. All right, so now we have another question here that says, how far will the car have traveled before stopping? So distance traveled is really s of t, right? Because acceleration is meters per second squared, velocity is meters per second. We just want to know how many meters it traveled before stopping. So that means we need to do it again. So we need to find s of t, which is the integral of negative 3, or the antiderivative of negative 3t plus 30 dt. All right, so my function will be s of t is negative 3t squared over 2, and then plus 30t plus c. Now, since they haven't really given us any information, we are going to assume that at time 0, because we only care about the distance that we started braking, so we're going to say that actually at s of 0 is equal to 0, because at time 0, I'm just starting to decelerate, so I haven't traveled at all, okay? So we're going to use this idea here. So I know that if I plug 0 here, and I plug in 0 in all of these things here, okay, so when I did the antiderivative here, I added 1 to the power. Here I got negative 3 and plus 30t, and then I add a constant. So now I know that s of 0 is 0. Now when I plug in 0 here and 0 here, that's all 0, so I find out immediately that c is 0. So that means my position function here is just s of t is equal to negative 3t squared over 2 plus 30t. Now I want to know how far it traveled, so in the first 10 seconds. So in this case, we're just going to pop in 10 here, s of 10, because that's when we found the car stopped. And we get -3, and 10 squared is 100, over 2, plus 30 times 10, which is 300. So I can simplify this. So I end up with -150 plus 300. So it will have traveled 150 meters, since I have 100 and, -3 times 50 gives me -150 plus 300. So I have traveled, the car traveled 150 meters in those first 10 seconds.